All right, so what we're going to be doing next in the unit is we're going to look at volumes that are found by taking a curve and rotating it around an axis. So we're going to say volumes formed by rotations and so we're going to write some things first and then we'll come back and kind of address it. So we're going to say the integral of cross sections. That will make more sense in a little bit. And the formula for volume is that volume is the integral from a to b of a of x dx, where a of x is the area of the cross section. Okay, so we're just going to jump right into this so you guys can see it, and then I will answer questions as we go later on. So we're going to talk about two different methods. The first method we're going to use is the disk method. Okay, so first we're going to find the volume of the solid formed by rotating the region bounded by y equals square root x, y equals 0, and x equals 1 about the x-axis. Okay, so I'm going to go ahead and draw a picture of this. So we have a square root curve, and square root curves look like this. And here's the point 0, 0, and this is the point 1, 1, because the square root of 1 is 1. So what they're saying is we're going to pick a point on the curve. Right here, we're picking a point on the curve, and we are rotating it around the x-axis, and we're finding that area. So if you can picture this, if you have a point and you're rotating it around the x-axis, it's forming a circle because it's going to be an equal distance all the way around the x-axis. And then we're going to take another point and we're going to rotate it around the x-axis. And then we're going to take another point and we're going to rotate it around the x-axis. So what I'm actually going to do is I'm going to show you guys a little app that's on my phone. Hopefully you can see this. Okay, so down here, here's the picture of the curve that we have. So we have the axis that the axis of rotation is the x-axis, and I'm going to show you this is what happens when I take one little sliver of that and I rotate it around. Okay, that's a little bit better. I had to adjust the lighting. So you can see that right here it shows where that little cross section is, and a cross section is just a slice. So if I take that slice and I picture like I had that point and I rotated it around, that's what one cross section looks like. And now I'm starting to have another one. And so here's what it looks like as I'm taking more and more cross sections, I'm taking more and more points and rotating them around. You can see that I'm getting this volume. So if you think about the formula for volume, it's area of the base times the height. So right here it's like the width is our height and the area of our base is whatever the length of this is right here, and it's rotating it around, so it's making circles. So the volume of this is going to be the area of the circle multiplied by the height. But the areas of our circles are changing. They're not all the same area. And you can see that as I get more and more cross sections, that this becomes more and more solid. So it's that same idea of a limit, where the more we get, the more accurate our answer is. So you can see all these little cross sections, and if I do it like forever, then it just is going to turn solid red, but you can see I've got a lot of cross sections in there. So what I'm going to do is I'm going to go back, give you less so you can kind of see the space in between these. And if you can see, do you guys see how those are like cross sections right there? So it's like a little slice, and it's been that little pin line right there is the x-axis. And so it's a point that's just spun around the x-axis. It's been rotated. And so it's making all those circles, and when we have enough of them, it makes a volume. Okay, so hopefully that makes a little bit more sense. My drawing's not perfect, but once you get enough of these, you can see how you end up getting like a thimble sort of shape. Bunch of circles. Okay, so what we've got here is that when we use the disc method like that, our cross sections are circles. And we know what the area of a circle is. The area of a circle is pi x squared, or I'm going to say, not going to call it a of x. I'm just going to say the area of a circle. Sorry, guys. Okay, the area of a circle is pi r squared. So here we're going to go ahead and look at what our function was. That was y equals the square root of x. And the square root of x, this right here, is how we figured out what our r was. So the radius of the circle is right here, or the radius of the circle is right there, or the radius of the circle is right there. So each radius is determined by taking an x value and plugging it into the curve. And so we're going to say the radius of the circle is square root of x. Whatever x value I happen to plug in is going to spit out a y coordinate that is the radius of the circle for that cross section. So if I want to find the volume of that little thimble shape that I made by rotating that curve around the x-axis, then to find that volume, I'm going to say the integral from 0 to 1, and that's because we were bounding this from 0 to 1, is pi r squared. So the area of our cross section was a circle. So we're going to say pi r squared, and we know that instead of the r, we're going to use the r that we have, which was the square root of x. So pi r squared dx. And I could do this by hand, but at this point I think it's safe for us to use a calculator to solve some of these. And so math 9 from 0 to 1 of pi times square root x squared dx is 1.571. All right, and we could go ahead and put units cubed on it because we do know that it's a volume. Okay, we're going to do another example. We're going to find the volume formed by rotating the region enclosed by y equals x to the third, y equals 8, and x equals 0 about the y-axis. So I'm going to go ahead and sketch a picture of this. So x cubed is an S curve that looks like this. Y equals 8, so our first point, we've got 0, 0, then we've got over 1, up 1, and we've got over 2, up 8. So y equals 8 would be somewhere right there. So there's my horizontal line. and then x equals 0. So x equals 0 is right here. So that means that the area that we're spinning around would be this area right in here. So on the last problem, if you were to picture the area that you were spinning around, it was this area right here. And this time it's going to be this area right here. So you can see, I'm not able to show you guys on the app because this is spinning vertically. It's in terms of y when we write our integral instead of in terms of x, and my app doesn't like that. But you can see that the picture would be about the same. So if we picture this, we're going to say that this point, if we're spinning it, is going to spin kind of this way. And spin, it's going to make that circular shape. And then this one is going to spin and make that circular shape again. It's going to spin and make that circular shape. So it's still going to be the same shape, it's just going vertically instead. So here, again, the cross-section is a circle. The area of the cross-section is still pi r squared. And so here, if I want to think about what I would have to do to find the radius of that circle, the radius is actually going to come from the x coordinate instead of the y coordinate. And the way that that equation is written right now is that I plug in the x and I get y as a result. But since this integral is going to have to be written in terms of y, then that means we're going to want to be able to plug in a y coordinate to get our x value for the radius. So that means I'm going to need to take this and solve it for x so that I can plug a y in and get an x as a result. So I'm going to go ahead and cube root each side. So that means that x is the cube root of y. And now I'm ready to go ahead and figure out how I could find my radius. So my radius is the x coordinate I get when I plug in a specific y value. So that means that my radius is the cube root of y. And so my integral would be from 0 to 8, so from 0 to 8 of pi times r squared dy. All right, and you can plug it in terms of y if you want, or you can plug it in terms of x. Your calculator can handle these either way. So Math 9, I'm going to go from 0 to 8, and I'm going to do pi times the third root of x squared. Did I write that? Yep, I did. Times dx. All right. So 60.319 units cubed.